In the previous talk, Professor Igor Schlauss, one of the things he said at the end is that actually we have to be careful that education is correct, and the correctness of education is obviously mediated by the correctness of knowledge. Knowledge is the greatest asset of humanity, and if we are speaking about transformations, paradigm changes, and so on, we must take into account that the greatest revolution in history is knowledge, and every new truth and every new piece of knowledge that is acquired is in itself a revolution, and it's the most liberating tool that humanity has found. What I really want to make in this presentation is to take into consideration the huge amount of knowledge that we have nowadays. It is almost a commonplace to speak about the vastness of knowledge. But from a philosophical point of view, I think that it is very important to find some sort of integrating ideas that can help us actually unite and reconcile different perspectives to find unity, which is always one of the goals of the human intellect. The exponential growth of knowledge is a fact. I mean, I mentioned the other day this Luciano Floridi has calculated that in 2012, more data have been produced than in the previous 5,000 years of written history. But not only that, between 2013 and 2015, we have passed from 4.4 terabytes to 44 terabytes. So 10 times more pieces of information. Of course, the value of information changes, and we need to be hierarchical, and that's the point of this talk. Actually, in approaching the world, and if we go back to the times of ancient Greece, the deepest truth is always know thyself, gnosis auton. But in order to know ourselves, we need to know the universe in which we are and the universe in which we take part. So, what are the fundamental tools that science, in this Promethean quest for knowledge, has offered us? I think we basically have three tools. And what I want to suggest is three fundamental categories that can help us find a unitary picture of the world. Many people wonder what can philosophy do nowadays in this world of exponential growth of knowledge, in which philosophy seems to have lost its place. Personally, I think that the task of philosophy, and especially epistemology, is to find the connections between different fields of knowledge in order to draw this unitary picture. These three tools are basically fundamental physics, evolutionary biology, and neuroscience. I want to stress the importance of neuroscience. Some people have done it because now I think it is the most powerful tool we have to know how the mind, not only how the mind works, but how we make science, because science, after all, is a product of our mind. Well, first of all, physics. What is the unifying potential of physics? I think that the unifying potential of physics is clear in two theories Professor Schlauss spoke about them, in the previous talk: general relativity and quantum mechanics. These are the most basic models we have, the two fundamental models we have, to explain the universe. Here we have the famous field equation of general relativity. It is an expression of beauty. If there is beauty, this is an equation which is an expression of beauty. How the curvature of space and time is related with the stress-energy tensor, how the matter tells the space how it has to be curved. And then we have the Schrödinger equation, another expression of beauty. Physics has not discovered the equation that rules the universe. We are still in need of a unification. But in any case, it has approached tremendously, dramatically, this Titanic dream, this utopia of finding a unitary explanation for the workings of nature. As we were saying, the two fundamental models are general relativity and quantum mechanics, and the problem is that they offer two divergent pictures of reality, and it is not very easy to reconcile both approaches. First of all, general relativity is a theory in which the force of gravity is contemplated as an effect of geometry. There is a geometrical interpretation of gravity. Gravity is actually the effect of the curvature of space-time. It leads to the formulation of generally covariant equations, which can be used regardless of the frame of reference. This is very interesting to notice that all great scientific revolutions in the 20th century, both relativity and quantum mechanics stem from a philosophical quest, from an epistemological quest. Einstein was wondering, how can we stipulate the meaning of certain ideas like space, time, simultaneity, and he got into special relativity and then general relativity. In the case of quantum physics, if one reads Heisenberg's papers, for instance, it is fascinating to see the degree of philosophical sophistication that we find in these papers. He wonders whether the traditional ideas of velocity, space, time, momentum can be applied to the microscopic world. So it is a philosophical quest. General relativity is the best explanation we have for gravity and for the cosmological scale phenomena, but for the three remaining fundamental forces of nature, namely electromagnetism, strong nuclear force and weak nuclear force, quantum mechanics has proven unsurpassed. I mean, it is unsurpassed. Here we have the famous equation for the standard model, the Lagrangian for the standard model, and the problem is that the picture of the universe unveiled by quantum mechanics is very different from the picture unveiled by general relativity. If in general relativity we have this geometrical view of force, in quantum mechanics we have a view of force in terms of particles, mediating particles, bosonic particles, which mediate the transmission of force. So this is a problem. How can we reconcile gravity as a geometrical effect and the three remaining forces as the effect of the transmission of force through particles? In any case, I think it is certainly admirable, I will not desist to insist on this, that in the 20th century, the human mind has found these two fundamental models, which provide us a marvelous unification of basically all physical phenomena. In any case, obviously, we know that there are still many questions opened, both from the work of Einstein and from the work of Heisenberg. This is also very beautiful, philosophically speaking, because that means that any new discovery in science will always open new questions. And, for instance, some of the questions we have is what is the meaning of uncertainty? What is the role of consciousness in the measurement problem in quantum mechanics? How do we transition from the quantum level to the classical level? Why, in a quantum scale, we need quantum mechanics, a probabilistic theory, but in the mesoscopic realm, in everyday life, we can actually use Newtonian physics, and we have a very good and very exact approach to nature. Also, a philosophical lesson that we can extract from the progress of science, and physics is the most basic of all science, is that any advancement, any great advancement in the scientific image of the world is normally triggered by a revisitation of our intuitions, by a criticism of our intuitions. This goes back to Galileo. The revolution against Aristotelian physics, which had prevailed for almost 2,000 years in the Western mind, came from a criticism of our intuitive knowledge. What we think, for instance, that a body which weighs more will fall before a body which weighs less. That was the famous experiment by Galileo. Or the very idea of inertia, the first law. So intuition is actually our enemy in the quest for truth, but we need intuition because we are always, and going back to the idea of a conceptual system, we could say that intuition and shared intuition is a conceptual system. We need it to navigate the world, but we know that if we want to make a progress in knowledge, we need to criticize our intuitions, and we need another conceptual system. This is physics, and this is regarding physics. But we have another extremely powerful tool to unify our view of the universe. And the beauty of this tool is that it actually provides the second step. If we have matter, and physics is the science of material entities, then we have life. And this is the great leap in the evolution of the universe, the origin of life more or less 3 billion years ago. Biology. And what is the most powerful unifying tool that biology can offer us? I think that it is the theory of evolution. We had a discussion on the last panel about evolution, but if we look at what evolution teaches us, it's extremely beautiful. That there is a continuation from the origin of life and the most elementary forms of life to us. So we are actually part of the same tree of life. And this is connected with physics, because physics gives us the basis. The model offered by Darwin, of course, with the new the evolutionary synthesis in the 1930s, with theory of evolution plus genetics, it unifies almost all of our knowledge regarding ecology, zoology, genetics, everything we know about the living beings. So I think this is one of the greatest discoveries of the human mind. If my scale to measure the importance of a discovery is accepted, this scale says that the greatness of a theory is based upon its unifying potential, the number of phenomena it can explain with the smallest number of principles, like quantum mechanics, relativity, and the theory of evolution. With a relatively small set of laws or set of equations, Einstein's field equations, Schrödinger's equation, we can explain an almost infinite number of phenomena. And this is the same with evolution. In the case of neuroscience, the third great tool I want to highlight, it is a very young discipline. We have here some neuroscientists, and they know that it is a very young discipline. Here we can see Dr. Ramón y Cajal, one of the pioneers of neuroscience. He discovered neurons. He won the Nobel Prize for this. So it is almost 1 century old. So we cannot, actually sometimes when we are critical of neuroscience because it has not offered certain explanations, we must be patient. We must be patient because it is a very, very young science. But from the level of nervous cells to the level of the most complex functions of the human mind, neuroscience is unveiling the thread, this Ariadne's thread that connects the atoms of the nervous system, so to speak, the nervous cells, the neurons, and the most complex tasks that human beings are capable of developing. As soon as we understand how the mind works, the origin of its abilities and the scope of its capacities, we will have a door opened for exploring the humanities. Because I think that if we don't have a unified theory of a unified social theory, it's because we don't have a unified theory of the human mind. After all, society is of course more than the sum of its parts, but there is no society without individual minds. It is all the fruit of our brain. We need to understand how the mind works if we want to have a good social theory, and especially a unification of our social theory. This is not deterministic. This does not mean that neuroscience will explain everything and will explain why we are here, sitting here in April in Dubrovnik. No, because there is a lot of contingency, but in any case it will provide the basis for this unification. Now, these are the three fundamental sciences, I think: physics, especially fundamental physics, biology, evolutionary biology, and neuroscience. But what are the fundamental categories that physics, biology, and neuroscience use? I think that in the case of physics, almost all physical discoveries, I would say all of them, converge into one notion, which is conservation. The greatest physical laws are laws of conservation. Here we have Emily Noether, who discovered Noether's theorem, one of the deepest physical truths, which relates laws of symmetry and conservation laws. Actually, the most important concept to express a law of conservation is the concept of action, which is energy multiplied by time or space multiplied by momentum. With this concept of action, we get all conservation laws. For instance, the principle of conservation of energy and the principle of conservation of momentum, which are two of the most basic laws in nature. In summary, physics has unfolded in spite of the vast complexity of subjects with which it deals and the complexity of equations and theories. After all, everything can be reduced to a matter of conservation of certain quantities in space or in time. Conservation in space, conservation of momentum, conservation in time, which is the conservation of energy, and then we have also the Gauge symmetries in quantum physics, but it's all about conservation of certain quantities. Symmetry. There is also spontaneous symmetry breaking, but the key idea to unify physics is symmetry and therefore conservation. What is the fundamental category of evolutionary biology? I think that it is selection. Selection in biology plays a similar role to the role played by conservation in physics. The great discovery of both Darwin and Wallace, we always forget about Wallace, but he was also a great scientist and he came independently with the idea of natural selection, is that variation, biological variation, genetic variation is selected by the environment. So this is the feedback process between the individual, the living being, and the environment. Selection is a key category in biology. And of course, the counterpart of selection is variation. So it is actually a two-sided coin. If we ascend in the scale of material complexity and we approach the universe of the human mind, is it enough to speak in terms of conservation and selection to explain how the mind works? I don't think so. Let me just qualify this statement. I think that there is a deep continuity in nature. Natura non facit saltus. I think that there is no real leap in nature. There is a microscopic connection. But this does not mean that we can explain all realms of matter, all realms in the universe, only with the principles emanated from physics. The category of selection is not important at all in physics. It is important in biology because we have reproduction. And so you need to select the fruit of that reproduction. So with the laws of physics alone, you cannot explain biology. Laws of physics provide the foundation for biology, but biology demands a neo-epistemological level. But ontologically speaking, I think that there is continuity. The same can be said regarding the transition from life to consciousness. The two great leaps, even if I have said that natura non facit saltus. Still, we don't know how life appeared on Earth, so we still are in quest of a theory that explains how we move from physics and chemistry into biology, and we don't know yet how consciousness emerged. I don't know when, in higher Paleolithic, but we are still in need of this theory that binds biology to neuroscience. In the case of mind, in the case of neuroscience, I think that the great idea is precisely unification. Conservation for physics, selection for biology, unification for neuroscience. What does the conscious mind do? Basically, it unifies perceptions. There is a famous philosophical problem, which is the binding problem. We get different stimuli of different nature, but actually we have a unified picture of perceptions. How is it done? Well, I think that neuroscience is now discovering how it is done, but the key idea is unification. This is an unusual privilege that the human mind holds. Of course, not only the human mind, it is an evolutionary capacity, which is the capacity of unifying the multiplicity of the world through the filters of rationality. This idea was highlighted by all great philosophers. We should go back to Greece, and this idea of legein, logos comes from legein, which is to unify, and this is the beginning of philosophy with Thales of Miletus in the 7th century, also Parmenides, but it is also key in Kant's theory of knowledge, the idea that the unity of a perception means that there is a subject that unifies perception, the Ich denke, I think. So these three notions, conservation, selection, and unification, are not strictly discontinuous. It is not a mathematically discontinuous function. Along its history, nature has been capable of rising on its own, before the human mind existed, from matter to life to consciousness. I think that we will be capable of reconstructing the path. But epistemologically, only with the laws of physics, we cannot explain biology and we cannot explain the human mind, and I will argue why. It is in fact possible to draw a narrow analogy between all of these notions, conservation, selection, and unification. Any law of conservation is based upon the principle of minimum action, the law of stationary action. Action, the product of energy by time or space by momentum, has to be stationary, has to take a maximum or a minimum value. This is a law of nature. It's probably the deepest law of nature, called Maupertuis principle. Also, the idea of natural selection, if we think of it carefully, it is also a principle of optimization. We are getting the best outcome from variations. Nature selects those variations which are optimal for survival. It is also an optimization process. In the case of unification, we can also see a process of optimization. It's an optimality, because the act of integrating perceptions in a unitary consciousness of external and internal realities is not only external perceptions, but also internal perceptions created by the subject himself, can be contemplated as a simultaneous optimization in the value of the information that comes from the world and the information that comes from the subject. An entity which is capable of extracting from this concatenation of a stimuli, which is huge. We are actually attacked by an almost infinite number of stimuli. So this filter, this inhibition of certain stimuli, is also an optimization in the value of information. That makes us more conscious of the value of the world, of information coming from the world and information coming from ourselves. The reduction of chemistry to physics has already been accomplished. Professor Slough said, chemistry can be explained physically, yes, especially after quantum mechanics. Here we have Wolfgang Pauli, his famous exclusion principle, explains how matter is organized, that two electrons cannot have the same quantum numbers. So that basically the mystery of the periodic table, thanks to quantum physics and quantum chemistry, was solved. The periodic table is the way it is because of quantum principles, and especially Pauli's exclusion principle, which is applied on fermions, particles that follow Fermi-Dirac statistics. In the case of evolutionary biology, there is a new semantic field in the universe. We cannot simply apply physical laws. There is a new semantic field, and we need new concepts and new language. Of course, it is based upon fundamental physical laws. It does not violate physical laws. There is no violation of the principle of conservation of energy, of Pauli's exclusion principle, but we need new concepts: replication, selection, and all what we know about genetics. In any case, we should not be naive and think that we have explained everything. The theory of evolution is a frame, but it is not completed. We are still working on a deeper theory of evolution. For instance, now with epigenetics, the Evo-Devo models, there is a lot of work to do. The theory of evolution, I normally compare it to Democritus. Democritus said that there were atoms, and he was a pioneer. He saw atoms, like particles which cannot be divided. But of course, he didn't have any idea of what these particles could be in modern terms. He was a visionary. Darwin was a pioneer. He gave us this beautiful frame that unifies all biological phenomena. But if we go into the details, we need genetics, we need epigenetics, and the topic is not exhaustive. Good. So the thread behind the transition from physics and physical chemistry into biology has not been entirely elucidated. We don't know how life was born. There are many theories, the RNA world, and so on. But it is reasonable to think that we will solve this problem. In any case, the impossibility of reducing the biological level to the physical chemical level does not stem from an intrinsic impossibility. It is epistemologically impossible, so to speak, but it is not ontologically impossible. It is not de jure but de facto. It's simply because we don't have sufficiently, we need deeper categories to make this transition. In any case, the complexity of a biological system is huge because it is not only necessity but chance. We have a lot of contingencies, and contingencies can never be reduced to necessities. So the Marquis of Laplace, when he dreamed of explaining everything from the initial positions and velocities of particles, that was a utopian dream which cannot be achieved even in physics because of quantum uncertainty. And I have the suspicion that if there is a God, not even God can actually exhaust all the contingencies that exist in nature. And there are, of course, fundamental prohibitions. I think that one of the beautiful discoveries of the 20th century is that we have limits to our knowledge in physics, Heisenberg's principle, and in logic, in thinking, Gödel's theorem. And when we go into the humanities, we have to take into account that the human being is a historical being, but also a biological being is a historical being. Darwin's theory is a theory of natural history. And in any form of history, we have contingency. Contingency can never be reduced to a law. We can have an approach to that law, but we cannot exhaust the phenomenon into a law. There are contingencies. It is not utopian, I think, to dream of a neurobiological explanation of consciousness. Professor Edelman made some very interesting considerations on this. But in any case, a neuroscientific theory of mind is not meant to exhaust every specific consciousness, our freedom and our subjectivity, because we are nurtured by constant interaction with the environment, and no theory can ever exhaust the complexity of the environment because there are many contingencies. It is utterly impossible to reproduce any single experience. We would need a one-to-one scale map. This is a utopia, because as soon as we are making the map, we are getting outside the reality, so we would never be exhausting the reality itself. And just to conclude, the language of science. Science is in possession of the most astonishing tool that the human mind has developed to express the laws of nature, which is mathematics. Here is the most beautiful mathematical equation, Euler's equation. We have all fundamental constants, E, I, pi, 1, and 0. And mathematics has proven very successful in physics. It doesn't mean that all mathematical theories can be applied to physics, only some of them. But in any case, we know that this depiction of reality, which is amazing, why is mathematics capable, a creation of the mind is capable of expressing the laws of the universe, the unreasonable effectiveness of mathematics, as Professor Eugen Wigner wrote. But in any case, we know, just to conclude, that there are at least two reasons why mathematics is not absolutely suitable for expressing the laws of nature. First of all these models, mathematical models, use differential equations. Differential equations presuppose a strict continuity in all levels. But in the quantum scale, we have discrete transmission of energy and discrete behavior. And also we have another problem which is more philosophical, which is the idea of equality. What does a mathematical equality mean? When we say, for instance, that something is equal to I, a square root of -1, of course we cannot be speaking in terms of material, real equality, because this number does not exist physically. It is a creation of the mind, a wonderful creation of the mind. So what does equality mean? But what is fascinating is that in many fundamental equations of nature, we find numbers like pi, with an infinite number of decimals, and the square root of -1. So this is amazing. But this means that this is an approach to reality, but it does not exhaust reality. The mathematical expression of physical categories is the deepest and finest approach to the material universe, but it is an asymptotic limit to reality. It cannot really exhaust and reproduce reality. We have managed to expand, in any case, the limits of our imagination, because mathematics is extremely flexible. Even when we think that something cannot be expressed mathematically, we always find a way to express it mathematically. The flexibility of mathematics. Until Cantor, it was thought that infinity could not be analyzed by reason. But Cantor discovers that there are different kinds of infinity, and the infinity of rational numbers is not the same as the infinity of natural numbers. Beyond all these difficulties, we look like Prometheus. We really want to steal the divine fire. And I think that this is actually a legitimate dream, and we have to go beyond. We have to move forward in this dream. We have one problem, which is logic. Our mind is ruled by certain logical categories, and we cannot escape. We can analyze the principle of non-contradiction, but in making science, we need the principle of non-contradiction to distinguish truth from falseness. But I have confidence that the evolution of the human mind and the deeper knowledge of how the mind works will actually help us flexibilize our logical categories, expand our logical categories, and realize that there are more things in heaven and earth than are dreamt of in our philosophy and our logic, so that the world will never cease to amaze us with unforeseen wonders, which are blessings for our intellect. This is the richness and inexhaustibility of the world, which in any case does not prevent us from finding fundamental principles behind the astonishing complexity of nature. Our mind, our logic, our intuition must be in a constant state of improvement, and they can be improved, they can be expanded. This is actually Leibniz's famous dream when he dreamt of a characteristica universalis. I very much admire his work. He's one of the greatest intellects, I think, in the history of humanity. And this unification of knowledge, this integration of knowledge, is actually finding a characteristica universalis flexible enough to open ourselves to new conceptual systems and new spheres of reality which are yet to come. Thank you very much.